Okay, so this is not going to be a revision session. So this session is on week 6. The next session is going to be a revision session. Okay, so with that, let us begin. All right, I hope my screen is visible. So week 6 is where we are going to start with classification related problems. So before that, we are going to first do an activity. So I'm going to pose a question to you all. Okay, so this is the question that I'm posing to you all. You don't know anything else about this. So you just know that it is some data set on which you're expected to perform machine learning. What do you do? Can someone start with what will be the first step you might do?
Find out what are the different variables in the data set.
Okay, find out what are the different variables in the data set. So can you give me some rough, say a title for it? What is the overall broad activity that you're doing?
Exploration.
Okay, exploring the data set. Okay. This is what I'm going to call it for now. And in this, what and all will you do? So you know nothing about the data set. Someone has just handed you the file and he has left. He told you you're supposed to perform machine learning on this and nothing else. How will you go about this?
Sir, first we can go for finding the number of rows and features.
Okay, find number of rows and features. Okay, what next?
Identify a target.
Okay, identify the target. Next.
Find the missing values.
Okay, find the missing values. Should I put it under exploring the data set itself?
That will be pre-processing, I guess.
Okay, so then I'll make another one called pre-processing, and I'll put find the missing values here. Okay. So firstly, sorry, 1 second. So there are no, I'm not looking for whatever is a correct answer or a wrong answer. I just want what you think is the approach. Yeah, please go ahead.
So the next step would be to decide what kind of problem it is, like if it's a regression problem or a classification
Perfect.
problem.
Uh, I'll put this as classification or regression. Okay. So as the doc also prompted, these are not the only tasks. But classification or regression as an example, I've put this here. Okay, what else?
We can look at the different like ranges of all the data and
Okay,
the distributions of the features.
observe range and distributions.
Distribution of features.
Okay, anything else here?
Whether the features
Sir,
are numeric or categorical.
Okay,
we
numerical
can
or
also see that which features are categorized by finding a number of unique values also. How many unique values are there in particular feature?
okay. Check
Sir,
unique.
scale of data. What is the scale of data on different columns?
Okay, scale of the data. Okay, anything else?
Look for output.
Sorry,
Look for output.
I think you're not clear, Prashant. Can you maybe speak closer or can you type it in the chat?
Okay, we can look for outliers.
Okay, perfect. Look for outliers. Okay, anything else?
If we have labels, like if we have names for the features, maybe try to pick up some domain knowledge about that.
Okay, look for domain knowledge. Very good. Anything else? Okay, so if that is all we have for exploring the data set, what else? So we have a pre-processing title as well here. Are there things I can add in this particular one?
Bring the features to scale.
Okay.
Impute
So
the missing values.
scale the feature, find the missing value. Okay, maybe I put it as a separate one.
Fit suitable missing
Impute
values.
the missing values. Okay, I think you were suggesting the same, right? Impute the missing values.
Yes, sir, imputation.
Okay, anything else?
Encoding the categorical features.
Okay, encoding the categorical. Okay, what else? After pre-processing, maybe what else can we go for? What would be the next, say, big step or something in this?
Building a simple model to see like the basic performance or something.
Okay, model building. So you want me to build a baseline model here. Okay. Anything else here?
So before this, you can do some visualizations as well to explore the relationships between the variables.
Okay, where should I put it? Should I put it in
After
exploring?
pre-processing, before model building, I guess, or maybe in exploring as well. Like I do.
Okay, so for now, let's put it in exploring, visualizing some aspects of the data set. Okay. What
So we
else?
can also make the graphs, let's say pie chart for any particular categorical feature.
Okay, so visualizing some aspects specific to the feature type, something like that. Right. Okay. Anything else?
We can look for the statistical values for this.
Group the statistical values. Huh?
Looking for the statistical values.
Okay,
The-
look for the statistical values. I think someone suggested something similar. Yeah, observe range and distribution.
Okay, okay.
I'll,
Same thing.
I'll maybe put statistical values as well. Okay. All right. What else?
Sir, in feature engineering, we can also draw any column which we find that it is no view.
Okay, very good. So let me add a feature engineering. Okay, so here drop features that are not necessary maybe. Just put it.
With similar values.
Sorry?
And the feature with similar values.
Features with similar values. Huh?
Yes.
Okay, features with similar values can be dropped. Okay, anything else in feature engineering?
Combining similar features.
Okay, combining similar. Okay, fine. What else? Okay, after apart from these four main sections, would you put up some other section for it? And like I said, this is not based on theory. After the end of this exercise, I'll give you what I personally would follow. We can discuss on that. So now, what would you guys do? So we've come up with so many things here. We have exploring the data set, pre-processing, feature engineering, model building. Are there anything I can add in between these, or are there any other broader columns that we can do? What are the tasks?
Sir,
So you're saying that after. Sorry?
train validation split.
Cross.
Super. So that was actually one of the things I was looking for. I'll call it splitting the data set. Train test validation. Okay. Anything else?
That last model evaluation.
Okay. Model evaluation. Model evaluation. Okay. In model evaluation, can you think of something? What do we do here?
We look at the performance metrics.
Okay. Performance metrics.
we can do hyperparameter tuning, try different kinds of models to sort of see which one works best.
Okay, where should I put hyperparameter tuning?
In model building, I think, not in model evaluation.
Okay, good. I'll put it as HPT. Sorry for using acronyms, but okay. What else? Can you think of anything else you might do in an end-to-end ML project?
Cross validation.
Okay, cross-validation. Where do I put cross-validation?
Model building.
Perfect. So cross-validation. Okay. What else?
Sir, we can make different models to find out which one is best and which will
Okay.
give the best accuracy.
Try out different models. Anything else here? Okay. So let's now go by these things one by one. So I'll probably go for a slightly different uh, ordering. But more or less, we've come to the similar points. So in exploring the data set, we have find number of rows and features, identify the target, classification or regression, observe the range and statistical values, are they numerical or categorical, check for unique values, scale, outliers, go for domain knowledge, visualize, and then some pre-processing steps, which is find and impute missing values, scale them, encode them. And then we have 3 points for feature engineering, which says drop features that are not necessary, and again with similar values. Is there anything else you all can think of for feature engineering? We actually did something like this when we did the week 2 practice assignment. I don't know if you'll remember. I'm not sure if that was the last session I took. Yeah, it was the last session I took, I think. So it was a movie data set in which we did some work. Do you all remember what it was?
So we have converted a string to a dictionary and date features to we took a year, date.
Yeah, extracting features from some complex form. That was one of the things that we did then. Right, and then for splitting the data set, we have train test validation here. And then we have few things in model building and model evaluation. Okay, so I'm going to go with the another form of the ordering. So this is what I want to put it in a different kind of a setup slightly. So I'll say first one will be understand the problem and the data. Okay. So for understanding the problem and the data, here again, as you have mentioned, is this a classification or a regression task? And then understand the target. I think this also is something you all said. Type of data. So while we normally work with tabular data, we can also have image, we can have text. So this way, understand the type of data. Then I think one of them mentioned shape. So which is, let's say, features and rows, maybe samples. Then we have things like were they numerical or categorical. I think this covered most of the things you all also said. Okay, so you all did get to this. Now I'll put exploratory data analysis. Simply write EDA. So I'm doing this because the first task is understanding the problem and the data. This is a very broad overview. And now in EDA, we come to very specific things. And as some of you all mentioned, I'll simply put this as basic statistics to cover things like range, the distributions, and the scale of the data set and all. Okay, so distributions also I'll include in this. Maybe the correlation. The correlation, I think you all did not mention it now, but of course it did come in, some parts of it did come in some of the things that you all said, but correlation is an important aspect. So it gives a preliminary view as to what are the features that might impact the target or interplay between features, because some of you all suggested dropping features that are similar. So correlation is one of those things that helps with that. Visualization, and here the other thing was check for outliers, missing data. And one more thing I will mention is, do you all remember the credit card fraud detection data set? What kind of a data set is that? we use a specific term for data sets like the credit card fraud detection data set. It has something to do with the distribution of the target variable, the classes.
Imbalance data set.
Right. So imbalance. So check for imbalance also is something we can do here. The next thing I'm going to call is data cleaning. And as I mentioned, this is just my view of these things. So I'm going to say remove / impute missing values, and then remove duplicates. So if you all had not mentioned, this is one of the things that you all might need to do. Handle outliers. Then we'll have handle some inconsistencies. Data. So what I mean by this is sometimes for almost a similar set of rows, you might have something that says entirely wrong, or it might use a different data type entirely. So you'll have some other errors that don't really fall into a bucket as such, but we can call it as inconsistent data. So with this, I'll come to feature engineering after this. And in feature engineering, the things I would say are encode the variables. So now encoding, by now you all will have realized that there are a few different forms of encoding. We can do one-hot encoding. We have label encoding for the target variable. Then we have what else? Ordinal encoding. Then there is frequency encoding, which I don't think there's a method in sklearn directly, but that is a very nice technique if you all choose to use it. Then there is scaling. Of course, scaling is, we all know what scaling is. There are again different methods for it. And some of the models that we might end up using are dependent on this scaling. With that, we come to feature interaction. So feature interaction, what I mean by this is some features might be influencing the others, and some of them we might even want to transform the features. Like we see things like taking log of it, creating a new feature out of it, those things. So extract features is another. This one we just discussed. If we want to take, if we are given a date and we want to take things like what day was it, what month was it. So just from a date time object, we can remove a lot of features. The other example is when we have some complex dictionary-like objects from which we take out things. So these all broadly come under this bucket. And then I would say feature selection. So feature selection, especially when we have data sets with a large number of features, this is something we'll want to do, and we can do it in different ways. One of them is through feature importance. And here I'm going to put use of domain knowledge as well. I think one of you mentioned this very important point that you can use domain knowledge to create new features also and specific features. So split the data set. And this one here will primarily put train, test, and validation. Along with this, I would say some things that you have to take care of is make sure it is representative of the original data set, and maybe handle imbalance. It's kind of on the same lines. Okay. Then we come to model training. Train simple to some complex models, and then cross validation and hyperparameter. And then we'll do some evaluation and interpretation. Okay, here the first thing I'm going to put is one of the common things that you all will see is the model overfitting or underfitting. So, simply because of how common and important it is, I'd like to stress about it separately as well. Underfit versus overfit. Then we'll try out different metrics. Then we'll plot some loss curves, and then we'll do feature importance. So feature importance will help with explainability primarily, and if you want to build a simpler model, we can make use of these things. Okay. So is this list okay? I hope most of you all are very familiar with things that are there here. I hope you all can agree that this is somewhat a general machine learning pipeline for a project. So I'll put as a caveat that these are only a few of the things, and you'll have to try out these things in different sequences and iterations. By the way, is there any noise from my end? Is this the keyboard noise or something present, and is it bothering?
No, sir, it's fine.
Okay, all right. Yeah, so this is what we have, and primarily our focus for this particular week will be on model training. And by model training, I don't mean that we are going to see all these three things, but if you all have seen the content, what we have with week 6 is on classification problem. So with that, let's start with some of the content. Maybe I can first open the slides that you all had. We'll do a bit of theory. We'll basically see how we would approach this problem. And after that, we can try out one particular data set as well. Firstly, there are a lot of methods in sklearn. So the way I look at sklearn is it is a bit like you choose to travel somewhere and you have these multiple options. Do you take the public transport? Do you go in an auto, in a bus, or do you go in your own car? And all these things, they have their own features. It can take so many people. It uses, if you take a car, it has so many wheels. It has, it's a 4-seater, 5-seater, 7 or 9. It takes in different kind of fuel, and it has these various features. So it is something that you're using to travel from one place to the other. It's not like you yourself have built the car from scratch. So sklearn is something like that. So it is giving you these finished products that you can use to achieve a task. And each of those things have their own specific behaviors to it. Some models will only work with some combinations. Some models can do some things, the others cannot. So that way you don't have full freedom, but at the same time, it covers most of the things that you need. So why I brought this up is that we cannot expect you or anybody learning to entirely know what is there in the sklearn documentation. So as and when we need something, we look it up and then we implement it. So that should be your goal as well. So you don't largely have to memorize a lot of things, but there are some things that become second nature the moment you go about it. Okay. So with that, we'll see some classification algorithms today. Specifically, we have a least square classification. In this case, it is nothing but your rich classifier. Then we have perceptron. I hope you all recollect perceptron from what you've learned in MLT. Then there is logistic regression classifier. And there are again a few things that says with regularization, that is whenever your model say tends to overfit, or if it tends to rely on a particular feature a lot, then you can go for something like regularization. And then you have this variant of a problem. We see either binary classification or a regression problem. But with that, we can also have multi-class, multi-label, multi-output, etc. And then there is cross-validation and hyperparameter tuning. We'll cover one specific thing that is relevant for specifically the classification setting. Okay. With that, here we see two things. The first is there is an SGD classifier, and they've called it generic. The reason it is called generic is because with SGD classifier, you can implement a few different algorithms. So what do I mean by that? So let's just go to it first. And you have to start getting very comfortable with using the sklearn documentation. Okay. So here I've opened the sklearn documentation for SGD classifier. Now, if you see SGD classifier, the first I'm going to parameter here. If you see loss, it takes in different values. Okay, there is hinge, there is log loss, modified Huber, and so on. And if you see hinge, it says hinge simply gives linear SVM. Log loss gives logistic regression. Perceptron gives the perceptron algorithm. And then there are a few more variants as well. So what this says is that if you use your SGD classifier, it is more of an optimization method. So if your SGD is nothing but your stochastic gradient descent. This also is something you all might have seen in MLT. So what this does is we all know that with these problems of classification or regression, we are trying to learn some function that predicts the output. You are given an input with some target, and you are trying to learn a function such that whenever I give it new input, it predicts a particular output. And this function has something called as weights. In most cases, it has weights. So this weight update, for that, we used to use SGD classifier as one of the methods, or rather gradient descent was one of the methods which we use to update our weights. So now likewise, what sklearn has done is they have given us this thing called as SGD classifier. And this is something that can change based on the kind of loss function you give. So as I mentioned, given that different loss functions, it is going to implement different things. That's why it's here under generic. And as you can see, for optimization, it uses gradient descent. That also tells us that there are different ways to optimize a given problem. And this also implies that there is a need for a loss function, because as I mentioned, gradient descent is for weight update. So only when you come to, say, your logistic regression or your perceptron, there is some particular function that you're trying to optimize. Okay. And now you can use specific methods as well. Here we have logistic regression, perceptron, and rich classifier for this particular week. We'll see each of them. And here is the key difference. Now, in this case, you can use specialized solvers. So what I mean by solvers, previously, whatever you had used gradient descent, now you can use some other approach to solve your particular problem. Okay. Now, then there is a common thing. Okay, I actually wanted to ask you all this question, but you all have seen in regression. Now, with sklearn, it is very simple. You first call upon a model, you import it from whatever package it is in. Then you call the fit method on x comma y. Then you predict it, and whatever prediction you get, you score using it. So now in the case of classification, can you all tell me what are some metrics that are there, evaluation metrics? Anybody?
So precision, recall, F1 score.
Okay, precision, recall, F1 score. And what is the one that is usually used by default?
Sir, mostly F1 score.
Okay, so the one by default that we have is actually accuracy. Okay, so accuracy, F1 score, and as you mentioned, precision, recall. These are some of the things. And if you again check the documentation, you'll see a few more functions there. So that way, these are very simple things. Any model you take, it can be your SGD classifier. In this case, for this week, it can be perceptron, logistic regression, or a rich classifier. Almost all of them follow the same setup. You fit, you predict, and then you get a score. And these are a few more things. There is something called as get parameter, set parameter. We might see a couple of them. And then there is densify and sparsify. So this is based on how the matrix is going to be, the final one. Either should it be dense or should it be sparse? This is again something I would say you don't have to bother too much about it immediately, but with time you'll get to know it. And then, okay, the first thing that we have is rich classifier. So this is what we are trying to optimize in the case of rich classifier. And if I'll recollect, this is the same setup that we had for least square. And this, what is this alpha W square? It is mentioned here, but what is it?
Regularization.
So this is for regularization. So what does this tell you? So in rich classifier, regularization is something that you can do. So let me open rich classifier as well. And now we'll go through this. Okay, so with the rich classifier, once again, you can see a lot of things. So the question is, do I need to remember all of them? Not really, but you should be able to use the documentation and explain what you have done. So firstly, what do you need to know more importantly than anything is, how does the model work? So you should, I'm not saying you should remember the entire derivations and all the formulae that you might have seen in MLT or in some of the textbooks, but you should have a rough understanding of what each of these models do. So the way sklearn has done for rich classifier is, here in a simple line, it says it first converts the target values to -1 and 1, and then it treats it as a regression task. Okay. So if you pass it as a classification problem, a binary classification problem, it is going to convert it to -1 and 1 and then make it as a regression task. And it has a few parameters that it takes. Firstly, we saw this particular expression. You are going to minimize this. This is your sort of your objective. And then you're going to apply regularization. So this is, why do we need to regularize? Again, you can go back to the lectures. So roughly, to put it simply, it is to penalize any weights that are blowing up too much. This prevents your model from relying on one feature a lot. So what are some methods of regularization? You all have learned at least two. Can you all name it?
L1 and L2?
Okay, L1 and L2. And do they have any specific names?
Yes, sir.
Ridge
Lasso
and
lasso.
Okay, so I heard lasso. What is the other one?
Ridge, sir. Ridge.
Okay, yeah. So lasso and ridge. So L1, L2, lasso and ridge. So this is what you saw in MLT, and these regularizers help us for that case. Now, and I think I had stressed this previously as well. A very good way to learn this particular course is to actually code and try out different data sets. And regularization is something you'll find is important with time. So if you have a data set with very few features, or even those with higher features, sometimes you might simply end up seeing that your model is too reliant on specific features. So in that case, regularization will end up becoming very important. Coming back to this, so these are some important things. So in rich classifier, alpha is the one that controls the regularization strength. And here it is going to tell you larger values specify stronger regularization. So this is one thing I would say with practice, you should start realizing this. So this is not exactly, I would not say this is something you're going to be memorizing, but as you try out a particular data set, you'll first start with alpha equal to 1. You'll realize your model is okay, not doing that great. Then you might increase it or decrease it. So with that, you are going to build an understanding that as I increase the value of alpha, there is stronger regularization happening. Okay. And this here, alpha is again specific to rich classifier. And then it says whether intercept has to be fixed for this particular one. There is a copy X. I'm not going to delve deeper into this, but copy X is a little relevant when your data set is being changed when you're building a model. So sometimes your data set can be modified. So for that, copy X is left as true by default. So it might not be something that you care too much. The next one it says is maximum number of iterations for conjugate gradient solver. And this value is determined by something, so and so. So here, again, this might look complicated, but it is simply saying what is the maximum number of iterations when I use this particular solver. And when we go to solvers, we'll see that there is a particular solver that is associated with this conjugate gradient solver. And for that, you'll need a maximum number of iterations. Okay. And then there is a tolerance. So this tolerance is, again, something that controls how long we are going to wait. So before we kind of converge or before we want to stop. And here we see many names, SVD, Cholesky, sparse CG. And the sparse CG is actually a sparse conjugate gradient. So this one is going to be relevant for that. And here you see some other things. It says when your solver is SVD, and what do I mean by solver? Is there another term that I might have used previously? Any answers? Yeah, so solvers here, did you all see some other one that was mentioned? What was the equivalent of solvers here that we had? Okay, why do we use solvers? Can someone answer that?
It's basically the algorithm that's used to classify, like on using SGD, right?
Yeah, so SGD is what is, or rather gradient descent is what is used in this generic classifier. So the solver is used for optimization, basically. And depending on the kind of model you use, different ways of solvers can be applicable for this. So again, in this particular one, going back to rich classifier, here you can see that these many different solvers can be used. And the reason why I stress that you might need to use the documentation a lot is because if you are using these specific solvers, for example, if you choose to use SVD or Cholesky or whatever, you can see that it has no impact at all. Yes, Sudhir.
Sir, can we say that solver is used to solve the NP hardness alpha?
Okay, I don't know if I would specifically name it NP hardness, but it is used to solve the function that you have. I'm not sure if NP hardness would be the right word, but I get where you're going towards it. So it's not that we have the exact solution, but this is kind of approximating to a solution. So this is an optimization method in that sense. Okay.
Okay, sir. Thank you.
Yeah. So, and as I mentioned, you see the documentation, you realize whether or not you have to set tolerance value depending on what solver you use. And this is again one somewhat important aspect, class weight. So we spoke about imbalanced data sets, and this is one way to kind of make sure your model itself is weighing the specific classes. Do you all have any other approach to handling imbalanced data sets? Did you all learn anything? So you find that your given data set is imbalanced. Did you see any methods in the course so far? Have you heard of SMOTE? Okay. Okay. I think it was there in the earlier weeks. If not, SMOTE stands for, I think, systematic oversampling technique or something along those lines. But the broader idea is that there are these two methods called as oversampling and undersampling. And in the case of oversampling, whenever there is a class with very few values and a class with a lot of values, for example, the credit card fraud detection problem, oversampling technique randomly it generates samples of the class that is lower and tries to match it with the one that is higher. Undersampling is the other way. The one that is higher is brought down to the same number of samples as the class with lower value. Okay. So the other way with models is to set class weight. And then there is solver, which there are a lot of things here. So a safe way is to simply choose auto, and auto will automatically decide what solver to use based on the type of data. Then there are a few different methods, and as I mentioned, I do not expect you all to memorize this whole thing, but there are a few important aspects. So if you see, both methods are often faster than other solvers when n samples and n features are large. So this tells you that if you have a lot of data points and a lot of features, SAG and SAGA are a couple of good methods that you can try out. But there is also another caveat if you continue. So they give fast convergence only when the features are on the same scale. So with this, what do you understand? What do you need to do with the data set?
Use a scaler before you put it through this.
Perfect. So all the features have to more or less be on the same scale before you use it. Can you name a model for which you don't need to scale your data set? Are there models for which you don't need to scale?
Sir, a decision tree?
Yeah, so decision tree and the models in that family, you don't need to scale your data set. But in case you're going to do this, so that is in case you're going to use something like rich classifier with SAG or SAGA, you have to make sure that you bring them to the same scale. Now, a question that you all can think about, I think this was also covered in MLT if I'm not wrong, is why there is a problem. Why would you need to scale? And this is something you all can think about. Okay. And then there are actually a couple of other things. Yeah, so LSQR, I think it stands for least square. Yeah, it stands for least squares. And you can see it is the fastest and uses an iterative procedure. Likewise, all of these things have some or the other sort of pointers to them. As and when you try out a model, you can come to this documentation, see what is relevant and update it. Then there is with LBFGS, there is another caveat that it can only be used when positive is true. So as you can see, there is this one called as positive, and it is useless to modify it if you are using some other solver. Then you have random state. Random state again is valid only for SAG or SAGA because this has some aspect of randomness to it. Like how do you shuffle the data set? What points do you start with? Something like that. So reading the documentation, is it clear? This was my primary goal out of this. Are you clear with how you would read a documentation for rich classifier, or at least classifiers in general? Can I get a couple of thumbs up at least if this is clear? If not, I'd like to go over this. Okay, all right. So one other thing that I'll point out is there is this read more in the user guide here. This is a very important resource, I would say. It's very helpful. Not sure why it's okay. Yeah. So here, when it comes to ridge regression and classification, this is giving you more details as to what it is doing. So I showed it to you with the slides here, but you can see the documentation itself has the same thing. It tells you that this is the loss function that I'm trying to optimize. And here, this is ordinary least square. So at least this first part is ordinary least square. And this part is imposing a penalty. And we discussed that it is the regularization. And here it tells you how alpha is controlling things. Larger the value, more the regularization. And with that, it also gives you some more details. It tells you that you can use simply auto. And if auto is given, it even tells you what is done. So it says if positive is equal to true, it will go for LBFGS. If the input array is not sparse, then it will go for this. And if these two things are not there, it will go for sparse CG. I think this should tell you that by default, that is if you go for auto, then it might not use SAG or SAGA. And if you wanted to use the SAG or SAGA, you know that it tends to be faster. And if you wanted it, you would have had to change it on your own. So this also tells you that you might not always want to leave everything to its default values. And here it describes how the problem changes for classification. There are also some other nice information here that says this classifier can be significantly faster than something like logistic regression. Logistic regression also will cover today. With a high number of classes, and it also tells you why it is so. So if there are those of you who are interested in the theory, then you can read about these things. But for those of you who are interested in mainly the practical stuff, you can take one data set, try running both these methods and see their speed. Okay, there's some more information. So do make use of this sklearn documentation. Now the difference will be for multi-class is that it will treat it as multi-output regression, and we'll see some more details of it a bit later. And I think we also discussed this. For all the classification methods, usually it is the same process. You import it from wherever it comes from. In this case, rich classifier is a linear model. So you import it from there, you instantiate it like this, then you call fit method. That's it. You're done with the model training. And as mentioned here, you do it on X train and Y train, and finally you use it to predict your test data. Okay. Some more things, we already discussed this. Alpha should be positive. Larger values give stronger regularization. Solvers also, we saw a few of them. Here again, it is giving a brief of the same. Yeah, so these are things we saw in the documentation. This is when it chooses auto. Which ones will it go for? Yeah, the other thing is the slides were prepared during the first runs of the course, and sklearn tends to continue being updated every now and then. So I'd again encourage that you be comfortable with the documentation. Yeah, so fit intercept, when would you have to do it? How do you predict? So once the model is done, the next method is predict. It gives you this prediction, and then you pass it to what your evaluation metric. Okay, so there is also a variant with cross validation. So can someone tell me what cross validation does briefly? Why do we need to do it? What does it do?
Cross validation is basically where you iterate over multiple versions of a training set and a validation set, and you train something on the training set and you see how effective it is on the validation set. Like it's mainly very helpful when you're doing hyperparameter tuning, where you can like see what is the best possible hyperparameter value that gives you the least error on your validation set.
Yeah, good. That is about what cross validation actually is. So again, there are a few different methods. We'll have k-fold cross validation, which is also the ones that tend to be commonly used in these, and it can also help you ensure that you're not overfitting on your training data. So yeah, and the other points that Kritika has mentioned. Then we come to perceptron. So yeah, so perceptron also, let's quickly maybe have a look at the documentation. So now perceptron, as you can see, it has a lot more parameters here. I'll go over a few of them, and then again I will let you all explore the rest as and when you all try things out. So the first one it says here is penalty, so which is nothing but your regularization term. And you have L1, L2, and here there's another one called as elastic net, which is kind of one that gives a balance. So you can a bit of L1, a bit of L2, something like that. And this is when you use elastic net, you can set something called as the L1 ratio, which is going to be a value between 0 and 1. And this says how much of L1 should be used and how much of L2 should be used. And there's also another part here. If it is equal to 0, as in if the L1 ratio is 0, then only L2 will be used. And if the L1 ratio is 1, then only L1 will be used. That way, even with the elastic net, you can try out these different specific regularization methods. Then, okay, let's have a simple MLT question. With perceptron, is it always guaranteed that the algorithm will converge? If so, why? If not, why?
I think no, because data set has to be linearly separable for perceptron to work.
Right. So with the case of perceptron, one of the things that the assumptions that we made initially itself is that our data set is going to be linearly separable. And as we know, and more often than not in a practical scenario, this does not tend to happen. So which is why one of the things that is done is to specify a max iter. Here the default is 1000. It says you do it for 1000 iterations. And if the algorithm does not converge, then you can just stop, and whatever weights are there at that point, you can give it. Okay, then there are a few more things. There is a tolerance, which is a stopping criterion. We saw it previously as well. There is whether you should shuffle or not. Then verbosity is how much it should describe things. And then anyway, as it continues, n jobs is for how much of your compute should be used. And this thing goes on. So again, there is a class weight here as well. And there is a warm start. So what warm start does is, if you set it to true, if it has done some training in the previous run, then when you call it fit again, it will make use of it. So what it does is, I've trained one version of, say, the perceptron. I've learned some weights. Then when I'm calling fit again, if I were to set warm start equal to true, it will take those as the initial values. Otherwise, you might remember from MLT, we might first take something like 0 for everything or 1 for everything. Some random initialization we do. So this warm start instead says whatever I've learned previously will continue building on top of that. Okay. So this is for perceptron. And as we saw, if we want to implement this using SGD classifier, we can simply give the loss to be perceptron here. And this will implement the same perceptron algorithm. Okay. Then we have the same steps here, some description of the parameters. Okay, there is one thing called as partial fit. This is to, as mentioned here, it is to train it using an iterative approach. So when you have large data sets also, this is something you can do. As and when you keep passing the data set, your model can go on training with each of these parts. So with partial fit, it learns something. And then since you've set warm start equal to true, when the next portion of the data set it sees, it builds on top of that. Okay, something along those lines. The final model that we have for this week is logistic regression. So let's quickly have a look at that as well. Yeah, sorry. So with logistic regression, again, it has a few parameters. Penalty that we already saw, and fit intercept, intercept scaling, class weights, random state solvers, and so on. So these, again, I'd recommend that you all go through this as and when you use it. And the user guide should have some more information. So here it is going to describe the logistic regression method. And as you can see, this is a common misconception. One thing that guys interviewing commonly like to ask is, what is logistic regression used for? So despite its name, it is used for classification. And the way it works is by using these logits or the log function, the logistic function. It's supposed to be some more, yeah. So here, this is what we use. So the probability, this is simply nothing but 1 by 1 plus e to the power minus w transpose x. So you all might have seen this in MLT. And then again, this is nothing but your cross entropy loss. And on the side, there is a regularization term as well, which is why when we were to go back to this particular, the first page, you see with penalty, you can give different kinds of regularization. And to solve this, you can again use different kind of solver functions. So which ones you can use are again mentioned here. And every now and then we saw this multi-class thing pop up. So normally in binary, what does it do? You have 0.5 or something as the threshold. When the predicted probability is greater than 0.5, you put it to one class. If it is lesser, you put it to the other. So, but in the case of multi-class, what can you do? So that is there. So here it says, then you can use this thing called as multinomial loss. And yeah, liblinear can only handle binary class. So if you want to do that, if you want to use logistic regression for multi-class setup, one approach they have given is that you can use this one versus rest classifier. What is it? Again, we'll come to it. Okay, so this is, we just saw the expression. There was a cross entropy loss and the regularization penalty. We saw it in this user guide. So this particular function, you have cross entropy loss and you have the regularization term. Again, you don't need to memorize all this. Just be comfortable with reading the documentation. How do you train it? Again, it is same. You just call it, you call the fit method, and then you predict. So again, for the choice of solvers in the case of logistic regression, there are some pointers mentioned. For small data sets, you can use liblinear, SAG or SAGA for large ones. This is again consistent with what we saw in, I think it was the rich classifier, that you can use SAG and SAGA. For unscaled data sets, again, it says you can, these things, liblinear, LBFGS, and Newton CG are robust. And we also saw the same thing that SAG and SAGA, you need to scale your data set. And what can you use for multi-class problems? It says these things will handle multinomial loss. Whereas if you're using liblinear, you have to use one versus rest. Again, if this is going over your head, totally fine. Just try these things out on your own and it will become clear. Penalty methods, again, we saw you can go for L1, L2 or use elastic net. In elastic net, you have to also specify the L1 ratio, which will say how much of L1 and L2 we require. There are also some more sort of combinations, and I was giving the analogy of using a vehicle with, it has some sort of settings to it or features to it that you have to live with. This is one of those things. Here, Newton CG cannot do L1 regularization. So if you choose to do lasso regularization, if you want to put L1 penalty, there is only liblinear and SAGA. Okay, so that is again something you have to keep in mind. Here it uses a parameter called as C for regularization, which is inverse of the regularization rate. So in rich classifier, we had alpha, which higher the value of alpha, higher was the regularization. Here, as you can see, it is inverse. So smaller values are stronger regularization. So again, this might seem like you might have to memorize, but the thing is, when you try out these different data sets, you will end up sort of getting these things in your memory by default. Okay. So to handle class imbalance, as I mentioned, you can use class weight. And there is the cross-validation version of this. And again, okay, there is some more with SGD classifier, which I'm not going to go into details of. But as mentioned, you can see these different loss functions. And depending on the kind of loss function you go for, different models will be trained. Of course, the famous ones that you will already know will be your support vector machine, or your logistic regression, and your perceptron. And here, if you see, these others are kind of slight variations. So squared hinge is hinge, but quadratic penalization. Modified Huber is smoothing it. So again, the details of it are beyond this. And quite often you'll see that even if you change these things slightly, if I go for hinge, modified Huber, square hinge and all, it might not really make that much of a difference. Okay. That is one thing. Here it's saying the same thing. If you use log, it's going to be logistic regression. In SGD classifier, hinge will give linear support vector. What are some advantages and disadvantages? Again, I'll let you all read this. Standardize the features. This we discussed it. So with gradient descent, make sure you scale the feature. And I left this as a question. Why do you need to scale in the case of gradient descent? So efficiency, ease of implementation again. So with gradient descent, it takes these small points, it does a weight update, then a next set, a weight update, and so on. So that way it is quite a fast method. Okay. Then there is some more theory. There's max iter is whenever there is a point of convergence. If the model doesn't converge, or if the weight updates are very, very slowly happening, then you can go for this max iter to stop it at some point. Okay, with SGD classifier, maybe this is one thing I'll touch upon. So there are these different ways. There is a learning rate. So I think you all might recollect, if your learning rate is too high, suppose there is a peak. Okay, there is you're trying to minimize something, and I think here my mouse might be visible. It's not that visible, but basically, if you recollect the curve that was there and a minimizing problem, I'm trying to get to the bottom of that curve. If my learning rate is too high, sometimes I can overshoot and I can go to the other side in my weight updates. So this learning rate is something that controls that. And there are different ways you can have learning rates. You'll learn a lot more of this in your deep learning course if you're doing it in your degree level. What these things will do is they are these different variants. For example, I'm making weight updates and say I'm going in the right direction. I'm taking these small steps in the right direction. So if I'm continuously going in the right direction, instead of taking small steps, I can take a larger step. And if I happen to be going in a wrong direction, then I can go with a smaller learning rate itself. So these are basically different variants of that. And again, as I mentioned, you learn more of this, specifically the theory and all that, in your deep learning. Okay. So this is a summary of these models. And then we have a multi-learning setup. Here I'll just show one part, which is very important. Okay, maybe I'll just show these things separately. So if you'll recollect during our initial discussion, I think one of you all pointed that we should identify the target. So sklearn has this thing called as type of target. And while you all might think that guessing if it is a classification or a regression problem is a child's play, there's a bit more to it. So again, I would not say that you should memorize this, but try and understand this. So firstly, if I were to give one particular sort of list with values 0.1, 0.6, it is continuous, the type of target. If it is just ones and minus ones, it is binary. Now again, it doesn't have to be just numbers, it can also be alphabets. So you have A and B, so again you have binary here. 1 and 2, it continues to binary. Now more than 2 classes, it becomes multi-class. Okay, it could again be numbers or it could be alphabets, it is multi-class. The next one is when you have not just one list, but a couple of lists. So what has happened here is that it is multi-class because you have 1, 2, and 3, but it also has 2 outputs. So it is multi-output. Then the next one is it has 1 and 2. And here, if you notice, instead of being as one list, it is within a list. So these things are indicators. So it is called as multi-level indicator. And then you have another setup where you have continuous values. Previously here you saw it was just discrete values, but now you have continuous. So it becomes continuous multi-output. And finally you have multi-level indicator. Okay, this is, again it is there. So here you have 2 setups, but it is multi-level indicator because you only have 0 and 1. Now these things are again described here. So just go through the documentation, check out some code snippet below, and with this you should know how a multi-class sort of target looks like, whether it is continuous, whether it is going to be for a classification problem with discrete values, and so on. Okay, then we have, I think there is one mistake here, so I'll just point that out. Okay, so this is what we just saw: multi-class, multi-output, multi-level indicator, and so on. Okay, so when we were doing logistic regression, we saw, I think it was liblinear that could not implement multi-class setup, and it said you have to pass it with the this one versus rest setup. So what this one versus rest and one versus one classifiers do, we'll briefly check that. This is not something you're going to be using a lot in your in practice, because usually the other methods itself will suffice. But I'll just briefly describe it. So what one versus rest does is, okay, so firstly the mistake here is it says one versus rest, which is OVR, and one versus one, it has marked as OVA here in the slide. But actually one versus rest and one versus all are both the same thing. One versus one is the different one. So in one versus rest, it is going to take one of your class. Say I have this, you all might recollect this MNIST data set. It takes digits from 0 until 9. So if I wanted to predict in that case, I can take one versus rest setup where one of the classes is going to be one of the digits and all the remaining are taken as the negative class. So I'm converting it into a binary setup where I'm breaking down these 10 classes into just 2. So one will be my target, the remaining 9 will be the other one, other class basically. So that is a one versus rest setup, briefly put. A one versus one setup, what it does is it fits one classifier for each pair. What I mean by that is, if you have say 10 classes, it is going to take a pair every time. That is, it is going to take say 0, 1, 0, 2, 0, 3 and so on. And it is going to fit a classifier for each one of them. So that way, the number of classifiers that you're going to get is 10 choose 2 in this case, because you had 10 classes and every time you want to see in how many ways you can pick 2 classes. So 10 choose 2 comes to number of classes into number of classes minus 1 into 2. You can do this. So 10 choose 2, if you apply the formula, you'll get, or rather if you expand it, you'll get 10 into 9 by 2, which is what is being described. So that is the one versus one setup. So here, if you continue, you'll see the same thing. So in one versus rest, you have one classifier for every class C. So it is going to say C versus not C. Not C includes all those other classes which are not C. So how many other classes you have, you'll have that many classifiers. And then you have the one versus one setup where you have one classifier per pair. And as I mentioned, you'll get K choose 2 classifiers. So that is the one versus one setup. Okay. So that is mostly the content that is there in this one. Evaluating classifiers, I'll come to it. Evaluation metrics is something that is going to be there a lot more in one of the subsequent weeks. So primarily, I'll cover it then. So briefly now you can see that for classification, you have accuracy, you have precision, recall, F1. It's also called something called as ROC, AUC. All these things we'll cover more in detail later. Again, confusion matrix and the display version of it, the classification report, all these things will come later. So far, is this okay, whatever we have seen? So we first saw, like, we took the end-to-end ML setup. From that, we saw that today we are going to focus on the model building part, specifically the classification algorithms. In classification algorithms, we saw 3 algorithms in perceptron, rich classifier, and logistic regression. We saw that all these, not all these 3, at least a couple of them can be used with SGD classifier just by setting the loss function. We saw that each one of them have multiple parameters, they work with different combinations, and it's a good idea to go to the documentation, understand them and implement them. Mostly it was that. Then we briefly saw how different kind of targets can be present and what we can do if we were to use, if we were to solve a multi-class problem. Okay, one thing I probably did not cover there is how you would actually implement this. So as you can see, let me first go to the first part. So in a one versus rest classifier, it takes in an estimator. So previously, if you wanted to use something like logistic regression with liblinear, you will set up estimator is equal to logistic regression and give liblinear as a parameter for the solver. And that is nothing but your estimator that is passed in. So we'll look at an example in the documentation itself. So they are importing support vector classifier SVC. And this SVC is simply instantiated and passed inside one versus rest. Okay. So if you want to use logistic regression, instead of SVC, here you are going to put logistic regression. That is all there is to this. Okay, so that is what we saw. And now I'm going to take up one data set and we are going to work on it together for some time. And that is what we have. Any questions on what we have done so far? Okay, all right. So I'm again presenting my screen. Can someone confirm if my screen is visible?
Yes, sir.
Yes, sir, it's visible.
Okay, all right. So by now, I hope at least some of you all are aware of this platform Kaggle. If not, I think we briefly took a session for it. We can go over it. So there's a platform where we can try out a lot of data science related stuff. So I worked on this particular data set. We'll go over what it is. Okay. So this is what is called as playground competition. Let me open the competition as well. So this is a classification task. Okay, and this is called as loan approval prediction. And in loan approval prediction, you have certain features. We'll see them. And you're supposed to predict whether or not the person is to be given a loan. Firstly, do you guys think this data set is going to be balanced or imbalanced? Any intuition about this? No thoughts on this? What kind of data set it might be? Loan approval prediction. Okay, so in that case, we'll actually see how the data set looks like. So yeah, now you'll have to prompt what and all code I can give. So how do I read a data set, a CSV file?
Read
Any
CSV.
answers?
PD.read CSV.
PD.read CSV.
And copy the paths.
Okay. So what else can I do now? Let me zoom in a little bit. Yeah. So what should I do next? I think you all had given me many points in the beginning. I'd like to hear a few of them. What and all can be done here?
Into data set.
See the
Sorry?
head of the data set.
Okay. Okay. So data.head. Now what? Yeah, so as and when you all suggest the methods, I'm going to write it. Otherwise, I don't know what I'm supposed to do here. Okay, you can see the data set here. How many features and columns are there? What should I do for that?
Shape.
Shape.
Okay, data.shape. Okay. What next?
Sir, is this Kaggle also available for us? The question which you're doing.
Yeah. So I'm working on this particular competition called as loan approval prediction. Let me put it in the chat. Okay, I've shared it in the chat as well. Okay, but what next? Methods. Shape is done, head is done. What can I do?
We can do info to see the null and non-null value.
Okay. Data.info. Are there any null values? Should I zoom further or is this good enough?
This is good enough.
Okay. Are there any null values?
No.
Okay. And anything else we can understand from this one?
We have some object types. We have to like see what those are.
Okay, perfect. Anything else I can do initially, now directly? Any other methods I can try out? Okay. So in that case, what we'll do is we'll first try and understand the dataset as well. So there were 13 columns. The first one is ID, which is just a unique identifier. Then we have person age. So when you see these values, they're obviously in years, but this is one of the things you'll have to pay attention to. So age, normally people say it in years, but what if the question was, say, validity of something, validity of a product? Someone might choose to give it in terms of months. Some people might choose to give it in terms of years, right? So if I were to understand if this is in what sort of range it is in, what can I do? What method can I use to find out? What might be the scale of it?
Describe.
Okay. So data.describe. So the person's age minimum is 20, maximum is 123. Wow, God bless him. But yeah, so person's age is most probably in years in this particular case. And then we have person's income. It says 35,000 and so on. Here, if we come further down, okay, 6.4 into 40. So around the mean is, I think, 64,000 in that case. Yeah, 64,000. The minimum is 4,200. Maximum goes for whatever this becomes. So that way we have the income. Then person home ownership. So I presume that this says whether or not the person owns his house, whether it's a rented or an own, whether he owns the house. And then we have person emp length, which is probably going to be for how many years has this person been working. Then there is loan intent. What kind of loan it is? Is it education, medical, personal, venture, and so on? And if I were to understand what are the different values this loan intent takes, what should I do?
Unique.
Okay. So what is the code for it? What do I need to write?
Data intent dot unique.
What was it called? Loan intent, is it?
Loan intent is.
Okay. And dot unique. Okay. So as you can see, there is 3, 4, 5, 6 classes that it takes. And then we have loan grade, which I have no idea of what those things mean in terms of banking, but I presume it again takes a few different classes. Then there is loan amount. Then there is loan interest rate, presumably what is the percentage of interest that is applicable for this particular loan. And loan percent income. So this is, here I think we saw the person's income, right? So what percentage of his income goes towards loan payments? And then we have CB person default on file, which is actually whether the person has defaulted on a payment of a loan. Now, for example, if I've taken a huge loan and say I'm paying it back monthly, so loan percent income will be what percentage of my monthly income goes towards that repayment. And default on file is if I ever missed out on a specific payment. So N, I'm presuming, indicates that no, the person has not missed out. And probably the other one is going to be Y for yes. Then there is credit history length. This is for how long does the person have a credit history. So for each of y'all, there is going, this is usually in years. So there is going to be a value of this format for how long you have your credit history that can be tracked. Then you have loan status finally. This is whether or not the person was given the loan. Now, what you have to do normally when you work on a data set, and especially if you start looking at Kaggle, you see some of these really nice notebooks, but at the same time, you should understand that they have not done anything brilliant. So simply one thing that people do is the following are the descriptions of the features. Okay, something like this. And maybe I'll add a point like loan amount. Okay. So, and then they add a description. This specifies the amount taken as loan. And maybe if you have some domain knowledge, if you read about things, and if you have some sort of hunch, maybe initially you can write the loan status could be correlated with this. Okay, something like that. So this way, if you add your descriptions and what you understand, it is going to enhance the quality of your notebook. Because I think I might have mentioned previously, you're not always going to be working with audience who are well versed in data analysis or machine learning or even banking or whatever that field might be. So you have to make things as simple and as clear as possible. And some of it will be even this value counts that we did. You can simply say in our given data set, we see loans are taken for education, medical, personal, home improvement, debt consolidation, or venture. Okay. So this way, if you add more description to your data set, it gives a credibility for the things that you do. Okay. So with that, we have done some exploration, and maybe we'll do one data.correlation. And here is the correlation. And with loan status, if you see the ones that are, okay, there is a negative correlation with the income. So this is maybe again matching what we might think, right? If a person has a lower income, maybe he is not given a loan that easily. And employment length, probably because lower the employment, lesser the chance of him getting a loan. Then amount. So if there's a large amount, maybe banks are willing to give because they'll get higher interest and so on. Likewise with interest rate, with percentage of income and so on. Does percentage of income and loan amount have a correlation? So let's see that. Where is loan amount? Loan amount has 0.64 correlation. Again, I think one of you mentioned that there might be similar features. As you can see, this is the way to identify things like that. While this is not a very correlation close to 1, this is still signifying that there is a lot of correlation. That makes sense, right? So if the amount is quite high, maybe the person has to pay a larger percentage of his income towards the loan. Okay.
Sir.
So far, yeah.
There is a negative correlation with ID also. What is emphasized?
With ID. So, yeah. So, firstly, ID, as I mentioned, is a unique identifier. And we tend to drop this before we observe it. And this value also you can see is very, very close to 0. So this simply says that there is not really a correlation. And the other thing is there is something called as correlation does not always imply causation, which means that even if there is correlation, so there is this example of there is as the sales of ice cream increased, the number of people drowning also increased. Okay, there is a high correlation between ice cream sales and people dying due to drowning. So can you tell me what might be happening there? How does that make sense? Any thoughts on this? Okay, so what this is called as, it's called as a spurious correlation. So you might tend to see higher ice cream sales in summer, and summer is when at least people abroad and all tend to go more towards the beaches and all that. So, and as people go towards the beaches, the chance of them dying due to drowning is also common. So which is why there is a factor which is summer, and because of summer people go to beach and drown. At the same time, because of summer people have ice creams. So even though there is a correlation between higher ice cream sales and higher deaths due to drowning, so there is very little chance that buying ice cream is causing someone to drown. Okay, so that way, don't always believe a high correlation to mean that there is actually some truth to it. So as analysts, you need to scrutinize things. Okay, yes, some other values here are, yeah.
Those column have to be eliminated, right?
Correct. So this ID is a column you will not consider. So this one here, you can see person age and credit history length. Again, it's a strong correlation. So you can either choose to keep it or remove it. And since we only have 13 features, we can even go with keeping it. Okay. Now I'll speed things up a little because today's focus is to run a few classification models. So let's go to that. And I'm going to drop loan status and ID. Okay, so now I've separated this, and I had asked a question of what we think is this data set. So as you can see, this, can I call this an imbalanced data set? Yes, no?
Yes, sir, because you have a lot more zeros.
Right. So a lot more of them do not get their loans as compared to those who have obtained their loans. So to speed things up, what I'm going to do is, as you can see, I'm on notebook 3, which is because before this session, I've prepared notebook 1 and 2. So I'm simply going to copy the code snippet from that and we'll proceed. So there were 4 categorical columns. I think one of you mentioned that we also saw it in info. There is object, 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 and object. So these same 4 columns, I'm mentioning them as categorical columns. And here I've used a method called x.columns, which is going to give out all the columns of the data set. If they are not in categorical columns, then they are numerical columns. Okay. So I've made the separation, and here is a visualization. Again, it is something important. Okay, this is because I've not imported matplotlib from pyplot as plt. I think matplotlib might be the package. Okay. C1 is not imported. Okay, finally we get to this. So for the 4 columns, there are some visualizations. So here there is one sort of suggestion I can give you all. So in case you have a particular column with a lot, which takes in a lot of values, and here if you see there are 30,000 people who have rented homes, 25,000 who are on some mortgage, who have mortgaged their properties, and very few people who own it. Now, if you had a data set where there were a lot more columns and many of them close to 0, you can simply choose to club them. So this reduces the number of unique values a particular column takes. And now say I had 30 initially. And after clubbing, if I have only 5, instead of going for something like ordinal encoding, I can now go for one-hot encoding directly. Okay. So loan intent, again, we have a distribution. Same on loan grade. See here, this is one example. Maybe F and G, they are maybe not that different. So you can take those particular data points where the count of loan grade is F and where the count is G, and then check their impact on the target variable. If most of them end up having the same class, then I can probably combine the rows with these 2 things. I can give them a same class. Okay, something like that. And whether the person has previously defaulted, again, most of them have not defaulted, which is why we have this sort of distribution. Okay, so this is some plotting, some visualization. And as I mentioned previously, when you all are working things on your own, again, make sure that you're going to write detailed descriptions of all these things. Okay. Now, as for the remaining methods I'm going to use today, I'm going to first import them all. And once the import is done, let's first start with splitting our data set. Okay. So here, why did I use Stratify? Firstly, what is Stratify doing and why did we have to use it? Any answers?
For stratified random sampling or something like that.
Okay, but what does Stratify do?
Basically, it allows you to get a more representative sample in the train set and the test set.
Right. So we saw that there was class imbalance in this particular one, in this particular data set. So now, because we've used Stratify, now if you see why train and test, so 20% has gone to test, see here the ratio kind of remains the same. There is for 4,000 entries with 0, there is 6,000 entries. Whereas in the test dataset, which is the 20% split part, for 10,000 there is 1,000. So if you see, more or less the ratio remains the same. Now if stratify were not given, there's a good chance that your Y train might have all the points of 0 and 1, like with this distribution. Whereas when you check for Y test, it might mostly have points only from class 0. This will make it very hard to train and evaluate your model.
It is kind of shuffling the original data set.
Yeah, so this is going to sort of ensure that from Y, whatever it does the split, it maintains that particular distribution. Okay, so the original data set anyway, it already has this particular separation. There is this imbalance. It is not doing anything to the original distribution, but whatever splits we are making out of it, it ensures that it matches the original in some sense. Okay. Then we do the encoding. So here, what I've done previously is, we've even done it here. So there were 4 categorical columns. As you can see, all of them had very few values. So I'm fine with using one-hot encoding, because even after using one-hot encoding, it does not blow up the space so much. So what I've done is I first called one-hot encoder. I'm going to drop the first one, and then how should I handle the unknown ones? If I see new columns in my test data that I've not previously seen in train, I'm going to ignore them. And this sparse equal to false is another setting that just helps with the data set, how it is presented in some sense. Okay, and I use fit transform on my training data, specifically only on the categorical columns. If I'll recollect, this is where we made that split. We took 4 of them as categorical and the remaining as numerical. So for the categorical columns, I'm now running, I'm going to use one-hot encoding, fit transform on them, and on the test split that I've made, just transform. This is because we do not want information from the test data leaking into our model. Okay, so that is the encoding part. And once we encode, the data set is not actually going to remain as a data frame. So there was one method called as get params when we saw the slides. I told these are things that you might not use frequently, but this get feature names out also is something along those lines only. So you can use get feature names out to get the columns that are thereafter. Okay, maybe I'll just print it here once. And let me show the encoded columns. So now, as you can see, it has performed one-hot encoding, and there was one column called person own ownership, and all those things that are there, other rent, and there was mortgage also. So that is probably the one that ended up being dropped because it will have the same correlation, high correlation. Same with loan intent as well. There were 6 values here. I think we can see 5 of them. We have education, medical, home improvement, personal venture, and so on. Okay, so that way these are the columns. So now I've taken the columns, and for these categorical columns which have just performed one-hot encoding, I'm making a data frame out of it again. So if you look at xtrain encoded now, it is back to a data frame. Xtrain encoded dot head. So as you can see, these are just the categorical columns that have been encoded. So now that I've processed my categorical columns, it doesn't take a genius to know that we are next going for numerical columns. And I'm going to use standard scaler. Very straightforward. Just take the numerical columns, use fit transform on the training part, use just transform on the test part, and your data set is scaled. Once again, I'm going to convert this into a data frame. And again, we can have a look at it if necessary. But before that, let me just concatenate it. So concatenating, if you all have not used before, it is to combine 2 data frames. I had my categorical part, I have my numerical part, and to combine them, I'm going to use concat or concatenate. And axis equal to 1 says how you should combine it. Okay, so now that I've done the concatenation, I'm going to see the final data set after pre-processing. As you can see, this is how it is. All the numerical columns are now scaled with standard scaler, and the categorical columns are encoded. Okay, with this, now I think we can go for model building. So the first model I'm going to do is logistic regression. As I mentioned, you just call logistic regression. Already import we had done in the beginning. I told I'm going to mention some of the imports that I'll do. As I said, okay, it is here. So here I've imported logistic regression, ridge and perceptron from linear model, and now I'm going to call it. So logistic regression, use fit on X train final and Y train, predict it on the X test and get the accuracy. Okay, it says accuracy 0.9117, but there's also a warning. It says LBFGS failed to converge, total number of iterations reached. So this is where I said you don't need to memorize things. With this, you can see that there is a solver called as LBFGS and it did not converge. And there was also a parameter called as max iter, which can control these things. Okay, so that if you want to stop things early. Now, previously, you all have seen hyperparameter tuning. I'm going to quickly run one model with hyperparameter tuning for this as well. So what is this code snippet? I have, okay, this I commented out because it was taking too long. So there is different values of C that we are going to try. That is your regularization. Then you're going to try different solvers, liblinear and saga here. And then there is maximum number of iterations. With how many iterations do I want to stop? So for now, I'm going to comment this out again. So here, of course, with time, I would have experimented some more. You all can actually see that if you run your model for higher iterations or for different solvers, some of them take a lot more time. And as you guys move to the MLP project, you are even going to end up seeing that some models can take 3 hours, 5 hours, and even more. And in the case of deep learning models, it can even go to days. Okay, so that way, this is my parameter grid. I'm going to use grid search CV. My model is what we trained previously, which is logistic regression. Then param grid I've passed in here. These are the ones I want to try out. 5-fold cross validation. One of you all had described cross validation, so this is the same one. Here, scoring metric I'm going to try out is for accuracy, and jobs is how much of the CPU it needs to use. So you don't need to worry about it too much. And then you have best, you have fit. You're going to fit the model, get the best parameters, and finally predict it on the test and get the accuracy. So let me run it. Meantime, I'll continue with code snippets for the others. So this particular competition actually had ROC AUC curve as the metric. So while I'm not going to explain in detail what it is today, we'll see it in a subsequent section, in a subsequent session actually. And yeah, so now you can see with the hyperparameter tuning, it is 0.9120, which I think was okay. It is slightly higher than the previous one. So maybe with some more hyperparameter tuning, we might get some better values as well. So ROC curve looks something like this. So this blue curve is for our model. And ideally, the more closer it is to this, this axis here, to 0 on false positive rate and towards 1 on the true positive rate. Because what is true positive rate? How much it has predicted as correct, and false positive is how many of them has it falsely predicted positive. So this tests it for different thresholds. As I mentioned, we'll get into it some other session. But we want this to come hug this particular lines as close as possible. So that way AUC, which stands for area under the curve, is going to be high. So this dotted line is a random AUC, which has 0.5 area under curve. And our model now has 0.9046. This is what the models are being evaluated on. So now that we have done this, the next thing we want to do is we did it on train test split that we sort of created. We made that train test split, but the particular data set in question, it has a different sort of test data, right? So the next thing we are going to do is we are going to use that particular test data and see how our model performs on that. So I'll just directly copy the code snippet for it. Just 1 second. We are almost done with this particular objective. I think this should be all of it. So there's quite a bit, but what I've done is first is read the test file, then take the test IDs, drop the test ID column, and then we had learned a one-hot encoder on our training data set. So just use it to transform this test data, convert it into a data frame for the categorical columns. Same with the numerical columns. Take the numerical columns, use transform, and then convert it into a data frame, concatenate it, and then grid search was our model that we just trained. So as you can see, the model here is called grid search. And so with this grid search model, I'm going to directly predict, but here what I've used is predict proba. So what predict proba does is it predicts the probabilities. And because this particular competition asks us to give probability, so I'll just show you in the competition. If you go to data, it tells you how your submission file should be. So sample submission, as you can see, it has values like 0.5 and so on because it's probability. It's also mentioned here, your objective is to predict probability. That's why it is predict proba. And finally, I created a submission file because it wants it as a submission.csv. So the ID and the loan status, which is the predictions, are converted into a file and it is created. Okay, so it says submission file created successfully. But how do I submit it to the competition? I'm going to click on submit here. Since this is a competition that has passed, sometimes it throws an error. If it does, you might have to directly download the file and submit. And that I think we can see here. So if I come to the output, you can now should see a submission.csv file. So this is the one that we just created. So now this particular notebook that I ran for logistic, we use logistic regression, right? Yeah. So for logistic regression, we'll see how much it ends up predicting. So we should get a score here. This should take under a minute now because we just saw that all the cells ran quite quickly. So from, so this was for logistic regression. Similarly, I do have code snippets for perceptron and rich classifier, but it's quite similar. So you simply need to change a few things here, which I'm sure you can manage on your own. If not, we can cover it in the next session. Okay. So as you can see, the score I've obtained is 0.899 for this particular model. So if you go to the leaderboard, since there's a competition that has passed, I don't know if it gives you a leaderboard position. Okay, it doesn't give a leaderboard position, but you can see the person on the top, he has scored 0.96. So with ROC AUC, as I mentioned, higher the value, better. The closer it is to 1, the better. And even their solutions are present here. But yeah, our simple model also managed to come up to 0.899. So on your own, you can try out different models, try out different forms of encoding and different models as well. So what we learned today was logistic, perceptron, and rich classifier. But even in terms of classifiers, the ones that tend to perform very well are these ensemble techniques like random forest and boosting methods. Okay. So I urge you also to go to this competition and try out your luck here. You have seen the code snippet of one that works. You can maybe use this and try and modify. There's also some other nice ones here. You can go to code and go for most votes. Okay. There's already a model with a score of 0.96. So we can have a look at it. So here you can see this yellow circle here. So if you can achieve that, your chances of getting a good jobs also will probably go very high because that signifies a Kaggle Grandmaster and it's not a very easy thing to achieve. So you can see how well these notebooks are present. So this is what I would like you all also to get to this level, and these things tend to be done. Usually these competitions run for a month. So every day you get 5 submissions. You can't make more than 5 submissions. So people tend to prepare these good notebooks and so this presentation is there here as well. He has some more nice visualizations. So all in all, just go through this, try out these different models. They've mentioned their scores here. First, you can try to replicate it and then try to go higher. Okay. So that was it from my end. Any questions on today's session?
Sir, will we be able to access that code that you edited?
The one that I wrote today.
Yes.
Sure. I mean, I can provide access to the code, but if it is to try out this competition, I'd say you just go to this competition link. I think I posted it previously as well. So let me post it again. Go to this link and actually have a look at all these other notebooks. Because what I did is something I tried in the 1 hour before the session. But I would recommend that you read these notebooks and improve upon your skills. Because the more you practice this, you're going to get a lot more better. Okay, so I posted a link to the competition. Go and have a look at these other notebooks. They'll also have the code snippets to run and get a model. If not, you put up a post on Discourse. If you are not able to make a submission, then I'll come to the post and I'll give a code snippet on how we can do it and assist you with it. Okay. Any other questions? All right, guys. That's it from my end.
No, sir.
Thank you. Okay. Yeah, that's it from my end. Thank you for joining. The next session is going to be a revision session for quiz 1. And I'll see you all in some session next month probably. Of course, you'll have sessions from the other instructors. All right. Thanks, guys. Bye-bye.
Thank you, sir.
Thank you, sir.